Alright, so today we're going to be adding and subtracting our rational expressions. So just like when we are adding and subtracting regular fractions with just numbers in them, we want to rewrite them with a common denominator. And then once we have that common denominator, we can combine the numerators, keep the denominator the same, and then we'll simplify from there. So there is quite a few steps in adding and subtracting, but just stay with me. So on number 1, we're looking for common denominators, and they both say 4a squared. So we're good to go on this one, and we'll just combine like terms, keeping the denominator the same. So 13a plus 5a, we can even write it like this so you can see every single step. And so that's 18a over 4a squared. And then we will simplify the fractions. So just like if we would have gotten something like 2 over 4, then we would simplify and say, well, that's 1/2. We'll do the same thing with our variables. So 18 and 4 can both be reduced by 2. And then a over a squared, there's no longer an a on the top, but there's an a on the bottom. So it gives me 9 over 2a. Now on number 3, we see that we've got a little bit more to do here. So remember, we're looking for common denominators. They both say y squared minus 9. So I'm going to add everything on the top. And then keep that common denominator. Then I will combine any like terms, so we've got y squared plus 10y plus 21. And then on the bottom we have y squared minus 9. And now we need to simplify. So I'm going to factor both the top and the bottom. So we need two numbers that multiply to 21 but add to 10. And they're 7 and 3. And then y squared minus 9 is a difference of squares, because 9 is a perfect square. So we've got plus and minus that square root, which is 3. Then I see that I've got y plus 3, y plus 3. So this would simplify to y plus 7 over y plus 3. Oh, one of them should say minus. There we go. So this is y minus 3. Number 5, we have a common denominator already. These are kind of hard to read just because the space didn't print on there. So number 6 is a plus, number 5 is a minus. We look for common denominators first. They are common, so we will add on the top. So minus n. And remember, whenever we subtract things, we are subtracting that whole thing. So we're subtracting n and we're subtracting 1. And the denominator stays the same. And so I'm going to combine my like terms. So 3n minus n is 2n. Negative 7 minus 1 is negative 8. And then n squared plus n minus 6. We'll factor both the top and the bottom. So that way we can cancel out anything that's the same on top and on bottom. So on the top, we need two numbers that will multiply to negative 8 but add to 2. So that's going to be positive 4 and negative 2. And on the bottom, we need two numbers that multiply to negative 6 but add to positive 1. And that's 3 and negative 2. We got n minus 2 on top and on bottom. So that leaves me with n plus 4 over n plus 3. Now on number 7, we do not have common denominators. So we have a 2x and a 3x. So if we have, let's say, we had 3/5 plus 2/3, we would find a common denominator. And so we want to find the smallest number that they can both go into, which would be 15. So we know that we're multiplying by 3 and we're multiplying by 5. So here we would have 10/15, and here we would have 9/15, and that's how we would multiply to get our common denominator and then add them together. So on our fractions with variables, it works the same way. So we want to get these to look the same, and so the smallest amount that I can get them to be the same with would be a 6x on the bottom. So in order to get to 6x, I had to multiply by 3 and by 2. So on 15, I'm going to multiply by 3, which is 45. And then with 16, I'm multiplying by 2, which is 32. And now they have a common denominator. So my new fraction would be 45 minus 32 over 6x. And 45 minus 32 is 7. And 7 over 6x will not reduce any further, so that would be my final answer. So on number 9, we see that we do not have the same denominator. But 5k minus 10, I can factor out a 5. Now I need a k, now I need a negative 2. And I see that that's the same as right there. So in order to make them the exact same denominator, I would need to multiply that second fraction by 5. So I've got k squared plus 16 minus 4 times 5, which is 20, over 5k minus 10. So I gave them the same denominator. The first one didn't need to multiply by anything, so I kept the k squared plus 16 the same. The second fraction needed to multiply by 5 in order to make it with the same denominator, so I subtracted 20 instead of 4. So now I've got k squared minus 4 over 5k minus 10, and now we'll simplify. So k squared minus 4 is the difference of the squares, so I have k minus 2 and k plus 2. And 5k minus 10 we know is 5 times k minus 2. So on top and on bottom I have k minus 2. So simplified, my answer would be k plus 2 over 5. On number 11, again, we need to make common denominators because we see that they're not the same. So I'm going to factor the first one and see what I need to multiply by. So I'm going to leave the top the same and factor. Two numbers that multiply to 6 but add to 5 would be 1 and 5. Sorry, 1 and 3 and 2, sorry. So we would have x plus 3, x plus 2, plus 1 over x plus 2. And so I see that one of them has x plus 3 and x plus 2, and the other only has x plus 3. So I'm going to multiply the second fraction times x plus 3. The first fraction doesn't need it because it already has both of those in its denominator. So I get x squared minus 5, x plus 3, x plus 2, plus x plus 2, x plus 3, and then on top we would have x plus 3. And then we will combine like terms. X squared plus x minus 2 x plus 3, x plus 2. Factor the top. Two numbers that multiply to negative 2 but add to positive 1. Positive 2, negative 1. And there I see x plus 2 on top and on bottom, which gives me my simplified answer as x minus 1 over x plus 3. Now number 13, I have w plus 1 and w minus 7. So there's nothing that I can factor and nothing is in common. So when that happens, just like in the number example that I gave y'all, we had to multiply by the opposites. So one had a 5, one had a 3. And so the one with the 3 multiplied by 5, the one with the 5 multiplied by 3. So the same thing's going to happen here. The problem with the negative 7 will multiply with the plus 1, and the negative 7 will multiply with the plus 1. So now we've got both of them whenever we make our fractions. Let's see. So we would have 5 times w minus 7 on top, which is 5w minus 35. And then on bottom we would have both w minus 7 and w plus 1. I don't suggest that you multiply that out just because we will have to simplify in our last step. And then 8w plus 8. And so now they have the same denominator. So I'm going to write it as one single fraction, 5w minus 35 plus 8w plus 8, and w minus 7, w plus 1. Combine like terms on the numerator. 5w plus 8w is 13w. Negative 35 plus 8 is negative 27. And then w minus 7, w plus 1. And then 13w minus 27 cannot be factored just because 13 doesn't go into 27 and 13 is a prime number. So we can leave the answer like this, or we can multiply out our denominator. 13w minus 27, and then here we would have w squared minus 6w minus 7. So we only multiplied the denominator out because it did not factor, nothing canceled it out with the top since we couldn't factor the top. So then we just left it as it was, multiplied it out. Then on number 15, we need to make common denominators, but I have something that might have in common. So 4p minus 20 I can factor out of 4. Leaves me with p minus 5. P squared minus 8p plus 18 I can factor. Two numbers that multiply to 15 but add to negative 8 are negative 5 and negative 3. So now I can see what they need in order to be the same. This needs a 4. Let me write it as a fraction. This needs a 4 and a, that's it, this just needs a 4. So we'll multiply by 4 on top and on bottom. And then on the left side, we only have 4 and p minus 5. I need the p minus 3. So if I multiply everything by each other on the bottom, I end up with 4 times p minus 5 times p minus 3. And then on the top, we're going to have two different ones. So on the left side, we would have 2p minus 6. And on the right side, we would have 4p minus 24. So making this just one fraction, we've got 2p minus 6 plus 4p minus 24. And we'll combine our like terms. 6p minus 30 and 4p minus 5, p minus 3. Factor the top, I can take out a 6 from both, so 6, I'm left with p minus 5, and 4, p minus 5, p minus 3. P minus 5 on top and on bottom. And 6 divided by 4 is 3 over 2. So we're left with a 3 on the top, a 2 on the bottom, and p minus 3. We can leave it like that, or and go one step further and multiply everything by 2 on the bottom. So we end up with 3 over 2p minus 6. So then that's it for the notes portion of adding and subtracting our rational expressions. You guys are doing the right side, and so if you need anything, just feel free to send us a message, let us know that you need some help. And that's it. So make sure that if they don't have the same base, and these are split up for you guys to like bases up here up until here, and then the other ones are the ones where you're going to have to find that common denominator. So once you're done with this, just turn it in on Canvas, and then I will see you guys next time.